Hi, I'm Arno Vigen. This is about gravity being scaled Planck's constant to the cube root as electromagnocoupling so that off-axis is Boltzmann constant squared. The gas laws are really about 3D, so everything is in 3 dimensions, but the interaction, the blue arrows here, is between two in the direct line. As such, there are 2 dimensions that are invisible I. And so we will take x1, x2, and x3, and those 2 extra dimensions, x2 and x3, effectively linked as squared, becomes important to understand what's happening. So graphically, you basically think there's a interaction in one direction, but somehow there's also this release in 2 other dimensions that will eventually come back. And eventually, in thermodynamics, all dimensions must balance. So the spacing and the arrangement of all the molecules come back so that x1 equals x2 equals x3. So that's really the question here. So now I think of this, as you can see, as a dimension with a separate dimension squared. So that's really 3D, but it's 2 degrees of freedom, and the second one being squared. So in reality, all directions balance. Now, this only happens after stabilization in certain types of systems, which we'll explain. Now, the secret is that this is not just how thermodynamics, this is also really what the del function does. And so when you get lectures for students at energy volume, that really then applies a del function, say in the Schrödinger equation, you're really bringing it back down to this 1D direction with these 2 invisible release and reply directions. And it happens in many ways, which we'll explain next. So, well, I said that those 3 directions are the same. The energy gets distributed in 3, 1/3, 1/3, 1/3 in the equations we're doing, because they are independent. But in reality, we're going to end up with a 2/3 in the invisible I, because you've got 2/3 of the energy over there. And so now with the prior side, which is the multiplication of them for the coupling of this system, and the energy split as a sum, you end up with 2 equations and 2 variables. And thereby in HemiChem mechanics, we can solve 2 equations and get the Bose map. Let's see how that's done. So this is the famous paper by Bose that Einstein found and used to prove quantum mechanics for the ideal gas law. Now, importantly, you'll see over here on the blue arrows that he has a term that is h, and the term that is h frequency divided by the speed of light, and that whole thing squared. That's looking just like my on-axis and off-axis HemiChem mechanics. So instead of doing this as he did it, I think of this again as the cube root, the del function, but for 1 dimension versus a square invisible. Okay, now it's squared and then I. So it's not I squared where you get the -1. So this is the dimensionalization of what you see in that. Now, what he's doing is just the one equation, which is the multiplication, and he's not doing the 1/3, 1/3, 1/3. And this is how you can improve Bose's result. Now, Bose called it cylinder surface. So for subshells, that is longitudinal ring springs, so they are cylindrical. the axis, the magno-axis of the nucleus, then has a ring spring around it, and that's like the electrons are on a cylinder surface. So he's correct. But when Einstein applied this, he used that for the ideal gas law, which is not a ring spring. It is the full thermodynamics of relays off of other atoms. So the physical model is different, and math is the same. So this coupling happens, and now you get to the tricky part. And that is when you're doing this Planck's constant as hc times alpha, the fine structure constant, in reality, we've already had this concept called G. But Bose's equation is just using Planck's constant. But you don't need the energy of that gravity because gravity is already there. And so how do you do that? So the action needs not hc alpha, but less the accompanying, so less G. And that becomes Boltzmann's constant and true with thermodynamics. And that's the link in the important part of today's talk. So what happens is Planck's constant over here at the left gets derived versus those invisible off-axis relays, so 2/3 the energy, okay? So that becomes the directed cube root, the offset at the 2/3 group, and so we take HCA at the 1/3 and HC alpha at the 2/3, but the HCA at the 1/3 is gravity, and the HC to the 2/3 is Boltzmann's constant. Obviously, still with the off-axis interactions. And that is actually already there, as we're going to show, because Einstein used G as the curvature. He used that as the error correction that we needed when we used the Boltzmann constant. Let's see how that works. So now what happens is let's change Planck's law to understand and use this new coupling of G and KB as Planck. So the left presentation is how Planck presented. But first thing I'm going to do is I'm going to take the frequency and I'm going to convert it via de Broglie into wavelength. So it's a distance in the 1D direction that wave is propagating at the speed of light to get me to HC at the top. Now let's rearrange these a little bit so that now I have wavelength versus temperature, and I have an inverse coupling. That's Rayleigh genes. That's the slope before we do quantization. Okay, and so now you've got a pure link to Rayleigh genes and how this E function drops it off from that. But now I also have to sort of get that alpha in the top, so there's an extra alpha arrived. But that HCA over KB is Einstein's curvature. So now in this final version, I have a direct map to Einstein's relativity, which means we don't have to, we can eliminate that part of relativity. There's many parts, okay? And we have the fine structure. Now the fine structure is basically the scaling from the particle edge out to where those electrons are, as the square root then fitting into that 2/3 section. All right, so this presentation, basically the one in the middle here with the purple and the blue, is teachable to show how this works, and that's why I like it. So importantly, you get these relationships, Hg, and when you do that, and you get mins and maxes as division and multiplication. So when you do the division, you get Boltzmann constant. But what happens is when you do multiplication for the maximum size, the wholes, you get Boltzmann constant squared. And now you have basically back to that on-axis versus off-axis square, and the whole thing circles. So there are three constants, and they are fully linked. In the direct direction, there's this excess g, which is Planck's constant to the cubed, and in the off-axis direction, there is the 2/3 of Planck's constant that gets relayed to other atoms. And that's why Kb is the heat propagation factor, but it is directly related to Planck's constant. So gravity then is the cube root relay of that. So what happens is when you graph these with the identity, they're a perfect R squared. That's something that needs further investigation. Thank you. And I think that the SI, which has three separate constants, needs to be reevaluated to make them fully coupled and related to each other.